Now let's say there are two forces that act at a point, but they are acting at an angle. Okay, so let's say you have this point. So you have one force coming in that direction. Let's say that's F1, and there's another force coming in that direction, that is F2. Okay, and this is theta, and this theta is not 90 degrees. So that means we have two forces that are acting not perpendicular to each other. So how do we solve this? Again, you have to draw the triangle of forces. That one is a must. So actually, there are two ways to solve this. You can use triangle of forces, which I've showed you earlier. All right. On top of it, you can also apply the parallelogram law of forces. So you can apply parallelogram law of forces. You can apply triangle of forces. And when you are applying parallelogram of law of forces and triangle of forces, you can use scale drawing. This is the next skill. So you already know how to calculate using the one with the perpendicular, that means the forces acting perpendicularly. You saw how the application of Pythagoras theorem and trigonometric functions were used to calculate the angle as well as the magnitude. I will explain to you how you can use your calculation, but the emphasis is to give you another skill, what you call drawing skill. So we are going to learn how to use scale diagram drawing to get the resultant force. So that's another skill that you need to have. But before that, let me discuss. Okay. So first of all, you have to draw a triangle of forces. So again, remember what I told you. To draw the triangle of forces, you can start with any of the forces. Okay. So let's start with F1. So I draw F1. And then what did I say? All right. When you are at F1, okay, now let me do it slightly here. F1. So that means your initial point is that. So now you're arriving here. So at this point, you have to continue with F2. Okay, you have to continue with F2. So to continue with F2 means I must follow that direction. So that way. That's how I must go. So you must parallel to that. So I'm going to do that. Okay. All right. That's F2. Now, is F2 bigger than F1? So let's say it is. Let's make it big. Okay, so it's a bigger magnitude. Okay, so it goes like that. So now where is your initial point? That's my initial point. Where's my final point? That's my final point. So what do? I draw a line from the initial point to the final point. That's what I'm going to do now. Initial point, the final point. And then I give the direction. I can indicate with a single arrow. This time I fix it with a single arrow. Not necessary double arrow. Okay. Okay. This is my triangle of forces. Okay. I label it. That will be my F2. And that will be my result. Okay. So, do you know any of the force? I mean, any of the angles here? Okay. What about this angle? Do you know this angle? Now, remember, this is the angle between the two forces because both are converging. So that is correct. Now to get that angle is not theta. So remember that angle is not theta. Why? Because this is converging at that point and that is diverging. Can you follow? That's diverging, that's going off, that's coming in. So that's not theta. That's a mistake students do. They take that, they translate straight away here. No. So what you do is you construct a line here representing your F2. Okay, so yours is, see, that's F1. The F1 is converging to the point. All right, your F2 must be diverging. So, sorry, you lengthen that you do that. So not this. I mean, you can do that, but this is better, easier. So this is your F2. So this scenario, this angle is equivalent to that angle. Can you see? F1, F2. So your mathematics dictates that that angle should be 180 minus theta. Did you follow? That is important. 180 minus theta, and it's not theta. It's 180 minus theta. Okay, so that is important. Okay, so if this is alpha, okay, let's say this is alpha, then this will be 180 minus alpha. Okay, so that's your triangle of forces. Get that correct. Okay, now at your lower form, you've learned about Cosinus Rule, solutions of triangle. under the solutions of triangle, you learn what we call the cosinus rule. Therefore, that you learn in maths. So you can apply that law and use it and calculate and you get the answer, which we are going to do. All right. That means you will be, your focus is, of course, your main priority and focus is scale diagram drawing. Now, after that, I will use the cosinus law to verify. So I want to show you that you can verify what you have drawn and what you have calculated using the scale diagram drawing by using your calculation using the cosinus law. So you can compare and see whether you've drawn it correctly and how accurately you've drawn. So I'll teach you that. So that's a backup system. All right. So this is, so according to the cosinus law, f1 squared plus f2 squared, remember, minus 2 f1 f2 cos 180 minus this cos, this cos of this angle, and the whole thing squared. That's your law. Okay, that you learn in your form 4 at max. Okay, all right. So that's under the solutions of triangle. Okay, now you know how to draw that. So now what you're going to do is you are going to do the same thing that you did, but this time you are going to draw a scale diagram. In a scale diagram, the scale will be given to you. That means either you state the scale or the examiner normally will state and say, take 1 centimeter to be equivalent to 1 Newton. 1.0 centimeters equivalent to 1 Newton, because you're using a ruler, so the accuracy limit is 1 decimal point in centimeters. Okay, so if it is 8 Newton, if this is 8 Newton, you have to exactly measure 8 Newton. Then this angle will be definitely given to you. Let's say this is a 45 degrees angle. So you got to measure 135. That means use a protractor from here to here, exactly 135 degrees. Measure and then draw this force. And let's say this force is 10 newtons. So the length of this line must be 10 newtons, exactly drawn. And then always learn to check 8 centimeters long, 35 degrees, 10 newtons. Then you just simply draw. Once you draw, you find the length. Let's say, example, let's say this length happens to be 14.7 centimeters. So 14.7 centimeters based on my scale happens to be 14.7 newtons. So straight away you get your resultant force as 14.7 newtons. You just got to practice how to draw, that's all. Okay? All right? That's how you get it. Okay? We are going to do that now. Okay? Before that, let me fill up the notes there. Okay? All right? Go to your notes, everybody.